So the first thing we'll go over in the first tutorial is just running the Joe model itself too. So as we saw in the earlier talks, the Joe model has three different input files. One of them is the stressor response input file, which is the stressor response curves and the relationship. So temperature and effects too. The other is the stressor magnitude file, which is the actual value of the stressors for a location. And the third file is the location geometry. So it's just polygons for whatever spatial unit it is too. And then these are the three different input files for running the actual Joe model itself. The stressor response workbook is an individual Excel workbook. The default stressor response workbook when the app loads is for the Athabasca rainbow trout. But we're going to walk through a series of other examples there as well. So the stressor response workbook is laid out as follows here. So we can find an example of the stressor response workbook. If I go back to the resource link here, and then I go down to example data sets. And then in this example data sets tab, there'll be a stressor response workbook. And I can just click that link to download the file. And I'll open it here, and then we can all kind of have a look at it. It might be easier if you just look at the Excel workbook on your own computer, or you can keep using Zoom too. So yeah, so when I open up the stressor response workbook, this is one example for the Athabasca rainbow trout. There's it's formatted as follows. So there's a main cover sheet, and then there are a series of individual worksheets in the Excel workbook that have the individual stressor response curves. So the main cover sheet just lists all the different stressor response curves, and then each of the worksheets has the actual curve data itself. The main cover sheet has some information about various kind of attributes, about whether there's like an interaction, it's going to be the minimum of them, like what's kind of like the function for scaling, and whether or not like how it's linked to the population model or the Joe model. I'll go through that later, but just for now, we'll just assume that all of these are just linked to the Joe model. Then when we go into one of the worksheets for the stressor response worksheet, they're all structured the exact same way. So there's the name of the stressor, the raw value. So in this case, it's like temperature on the x-axis here, and then the response. So kind of like the dose response, stressor response. And here there's also the opportunity to have stochasticity in the stressor response relationship too. So that means each time that the model will run, it'll sample a response value with a mean, like if the temperature is 13 degrees, it'll start with a mean of system capacity of 75%, but it'll keep resampling this in the simulation with a standard deviation of 10. And then there's these lower and upper bounds too. In the Shiny app, like what that actually looks like here is, so when we load this up and we have our stressor response workbook, this was temperature gold. So it goes to the main mapping tab, and then I can go look at this relationship too, and when it loads, it'll be the exact same thing we just saw in the previous Excel workbook, and it's the plot and the table. And then I can go in and change these as needed. So like if I wanted the stressor magnitude value at 4 to be a little bit different, like they could still something could still sort of survive, but there was lots of uncertainty around it, and then it could never go higher than let's say 40%. It is it's possible to kind of adjust these components in the tool, so you can kind of edit the stressor response relationship in real time there. So this example with the Athabasca rainbow trout is quite involved. There's a lot of different stressors in here. And a lot of examples, like when we saw with Lauren Jarvis with the suckers, so you don't need to have like a big library of stressors. You can still, it might be easier just starting with like 3 or so primary stressors there. There's a few different options you can include for your each of your stressors. You can say whether they're going to be linked together. So like if you have 3 stressors and you just want to use the minimum value of 3 of them, you can do that here, or maximum, or vice versa. There's some options about whether it's going to be a linear scale or a logarithmic scale. And then yeah, these were developed by Andy Paul here, and then also options about whether how you want to interpolate, if you want it to be continuous, or if you want to just assume steps too. So like in this one, there was an example with beaver dams, and it's steps too, so it's not fractional. So that's the stressor response workbook. I can actually upload that workbook into the application that I just downloaded. So let's say, actually, I'm going to change something here. So if I change one of these, and I make this 10 and this 9 and 9 or something like that, I'll save this in Excel, and then I can upload it into the workbook. So I go to, in the Shiny application, I'll go to upload data, stressor response workbook. And I'll upload that thing I just edited. And I don't have to update any of the other inputs. I can just update the stressor response workbook. And then when I go back to here, click on this relationship, and then I can see my updated values appear in the application too. So yeah, that's just kind of showing an example of how you can work with these stressor response relationships and update them either in the RShiny application in a workshop setting, or update them in Excel and do various work kind of offline there to get stuff set up too, and then to kind of upload different workbooks into the application and tool there. Yeah, and then this is, yeah, just another reiterating. So the stressor response worksheet has a cover sheet for all the stressors, and then it has individual worksheets for each of the particular stressors. The next kind of key input is the stressor magnitude workbook too. And so this is like for each of your locations, what are the actual stressor values there? So like, what is the temperature, what is the sediment, and so on too. And then in the CEMPRA toolbox, this input's described as the stressor magnitude workbook. So similar to the stressor response workbook, it's an Excel input here. It's just a single worksheet, but I'll just show an example here because it might be easier just for you to look at in Excel. So if we go back to this resource page, the example data sets here, oops. And then if I look at the Athabasca rainbow trout example, I'll download the stressor magnitude workbook, and I'll just open it up here to see what it looks like. So the stressor magnitude workbook is structured as follows. So this is this type of data format is it's a long format relative to wide, and what that means is for any given location. So in this case, oops, maybe I'll just go, yeah, Beaver Creek here. There's multiple rows for that one location to represent all the different stressors. And the reason it's formatted this way, as opposed to a wide format, so you might be more, oops, you might be more used to seeing kind of GIS data represented in this format, where you have like some ID for a watershed 1, 2, 3, and then another watershed and so on. But this format doesn't let you specify stochasticity around each of the variables. So instead of being in a wide format, it's actually displayed in this long format. So if I look at any individual location here, so this is watershed ID 1, 2, 3, and then it gives a name. And then for each of the stressors, their individual rows. So then there's a mean value, a standard deviation, the type of distribution, and then lower and upper limits. So in the Joe model, when it runs, not only will it just use like a mean temperature value, but it'll be resampled throughout the simulations based on, in this case, it's going to be a normal distribution with a mean of 11 or of 80 here, and then upper and lower bounds. And this format's pretty powerful too, because you can specify different locations to have different levels of stochasticity for different variables, and then the shapes can be different as well. And the default is just to assume everything's a normal distribution too. And then if you don't have any stochasticity, that's fine too. You can just set the standard deviation to 0 for all of them, or just leave those columns blank too. So that's what the stressor magnitude input data set looks like. Similarly too, I can go back to the R-Shiny application, and I can go upload data. Let's say I make a change to something in here. I can browse to my stressor magnitude data set and upload it into the tool. And this will, anything that you change in there will override and reflect whatever is in the app too. And this format, or this kind of workflow of like editing something in here and then uploading it into the app is pretty useful, because I could have different versions of these two. So it's like if I have one of these that's like, let's say my previous one was base case, and then this one's going to be like restoration alternative like A or something, and it would have different values in it. Or this would be climate change 2050 or something too, or plus restoration. So you can kind of make up different scenarios as different sets of stressor magnitude data, and you can upload them into the tool and just kind of keep cycling through that. Yeah, and so those are the basic inputs there. The final one is the location data too. So the location data can be uploaded into the tool as a shape file, so a GIS shape file or a geo package. In the examples, I'm using geo package, but you can also use a shape file there as well. And you wouldn't necessarily change your locations unless you're going to switch to like a different study system or do something kind of creative there.
Matthew, I have a question. Does it matter what projection your shapefile is in?
Yeah, that's a good question. No, it doesn't too. There is a special format it needs to be in. It needs to have a column called ID and a column called name. But it can be in any projection, and it just reprojects it on import too. Gray bars on. The idea is that like your locations are probably in the neighborhood of like 50 megabytes too, but if you have like a giant file that's like dozens of gigabytes, it'll probably not work on the online version there too. And then there's some tricks in GIS where you can simplify the geometry there. Yeah, so that's the format of the stressor magnitude data set. So, sorry, did that answer your question about the projection there?
Oh, yes, it did. Thank you.
Yeah, so again, the stressor magnitude data is this kind of long format. So each watershed or location has a series of rows, mean and standard deviation, and so on. And so the stressor magnitude workbook, so this was like kind of coming up with the stressor levels for a location. Like from the previous examples from this morning with Laura and Jessica, we saw examples where you can do like heavy GIS analyses to come up with your stressor levels too, or examples with Lauren too. Like you don't need to have these giant data sets either. Like you could focus heavily on kind of getting estimates from different field studies too. So just because you're putting values in Excel, that means that you can run this whole thing without really doing any GIS work at all too. So
could you not pull some of that data from like Climate WNA or Climate BC?
yeah, exactly.
Extreme temperature stuff.
So yeah, if you were thinking about yeah, and that would be the idea, is to try to find resources online that are pre-processed that have data as close as you can get to your target stressors too. So maybe that's Climate WNA, it could be LC's, that other resource, various components from like the BC cumulative effects framework too, that process a lot of different risk indicators, or any other kind of creative resources too that you can find. The CEMPRA toolbox itself doesn't actually generate the stressor magnitude data, but that's up to the user there to find their resources. Yeah, and so yeah, the last input's this locations data set too. And so the location input can be like a shape file or geo package there. It needs to have a column with ID and name, and it doesn't really matter whatever else is in it. Ideally, you want to make it sort of small-ish if possible. And there's a function in QGIS or ArcGIS or all those other programs called simplify the geometry too. And what that does is it just makes the polygons a little smoother, but the file size like exponentially decreases there too. So yeah, here's an example locations data, and then so this, like you might, like if you were generating a new data set, you might pull up QGIS or ArcGIS and maybe just kind of assemble your locations there before bringing them into the tool. Again, we can kind of see here, it doesn't really matter what else is going on in the file as long as there's two attributes with those names, because then that lets the location data match to the stressor magnitude data. Oh yeah, there's one kind of bizarre thing with the geo package file is like everything's in one, but I don't know on the call there how many people work with GIS files in the day-to-day, but shape files are actually split up into a few different files too. So there's like the shape file, the database, and the projection one. So when you're loading, a shape file into the tool, you just have to click the control key on your keyboard, and then when you select multiple files too. So when you're importing it, you have to just include all of them there. So I'm going to just show an example of what that looks like here. So yeah.
I've also got a question in the chat, I think.
Yeah, and it can deal with overlapping watersheds too. What'll happen is it just, when it's importing the data, it doesn't really know that they're overlapping, but it just puts the smallest one in the display to appear above the bigger ones below too. So yeah, here's an example where the shape files are a little bit annoying too. So I only just included one example, but you just have to zip them to upload them and then unzip them. But the idea was just to